This is the chapter everything has been building toward. Every concept you have learned in this course, triggers, matrix builds, secrets, OIDC, Docker, environments, and approval gates, is about to come together in a single production workflow file. This is not a toy example. What you build here is what real engineering teams ship with, the kind of pipeline that runs hundreds of times a day at companies that deploy with confidence. By the time this chapter ends, you will have a complete, battle-tested CI/CD pipeline you can drop into any full-stack project and trust on day one. The application is a full-stack project, a React frontend, a Node.js API backend, a Docker file, and a test suite covering unit and integration scenarios. This is the standard shape of most modern web products, and the pipeline we build for it applies equally to any containerized application. The pipeline has 6 responsibilities: run tests across multiple node versions, build a Docker image tag by commit sh, push that image to GitHub container registry, deploy to a staging environment using OIDC credentials, run smoke tests against the live staging URL, and then wait for a human to approve before deploying to production. Each of these responsibilities maps directly to a concept you have already learned. The pipeline is built from 5 jobs, and the dependency chain between them is the architectural backbone of the whole workflow. The test job runs first, in parallel across 3 node versions. The build job needs test to pass, and it only runs on the main branch. The deploy staging job needs build, taking the freshly pushed image straight to your staging environment. The deploy production job needs deploy staging, but before it can execute, GitHub pauses and waits for a required reviewer to approve. Each needs declaration is not just ordering, it is also a gate. If any earlier job fails, every downstream job is automatically skipped. The test job is the foundation that everything else depends on. It runs on every pull request and every push to main, catching regressions before they can ever reach a Docker image. The matrix strategy fans the job out across node 18, 20, and 22 simultaneously, 3 runners, all running lint, unit tests, and integration tests in parallel. Setting failfast to false is a deliberate choice. You want to see which specific node version has a problem, not just know that something broke. The npm cache key to your package lock.json means repeat runs are fast, typically shaving a full minute off install time. The build job only runs when a commit lands on main. Pull requests test the code, but they never push an image. This is a clean boundary. The registry only ever contains images that have passed every test. The Docker metadata action generates a tag using the commit sh, so every image is uniquely and permanently identified by the exact code it was built from. That sha tag is exposed as a job output, and every downstream job that deploys uses that same output. Staging and production always run the identical bytes. The built-in GitHub_token handles GHCR authentication with no extra secrets required. The deploy staging job is where OIDC authentication makes its full impact felt. There are no AWS access keys stored anywhere. GitHub exchanges its short-lived OIDC identity token for a scoped AWS role at runtime, and that role expires automatically when the job ends. Referencing environment, staging means this deployment is tracked in the GitHub Environments tab, giving your team a permanent history of what was deployed and when. After the ECS service update, the workflow pauses briefly and then hits the staging health endpoint. If that curl returns anything other than success, the workflow fails right here, and production never sees this change. The approval gate is not a script or a complicated action, it is a single line: environment, production. When GitHub sees a job referencing a protected environment with required reviewers, it pauses execution and immediately sends approval notifications to every member of the configured team. No single engineer can unilaterally ship to production. The 4ICE principle is enforced at the platform level, not by convention. GitHub records exactly who approved, at what time, and for which commit. This is your compliance audit trail, generated automatically with zero extra tooling. The workflow header contains 3 decisions that set the security and reliability posture for everything that follows. The permissions block at the top level is a ceiling. Individual jobs can only use what is declared here, so a compromised third-party action cannot quietly escalate its own privileges. The concurrency block with cancel in progress means that if you push a fix before the first deploy finishes, the older run is cancelled. You can never have 2 pipeline runs racing each other toward production. The test job with its matrix strategy then runs on every pull request trigger, giving you a complete quality gate before a single line of code reaches main. The build job exposes its image tag as a named output, and this is the mechanism that guarantees staging and production deploy exactly the same image. Downstream jobs reference needs.build.outputs.image tag. They do not rederive the tag or accept a latest tag that might have been overwritten. The deploy staging job then takes that precise SHA tagged image and deploys it to the ECS cluster, using OIDC credentials that never persist beyond this single workflow run. The health check at the end of deploy staging is the final automated gate. Smoke tests confirm the app is responding correctly in a live environment before any human even sees the approval request. The production deploy job is structurally almost identical to the staging deploy OIDC authentication, ECS service update, health verification. The critical difference is the single-line environment, production, which activates the protection rules configured in GitHub settings and pauses the entire job until the required reviewer approves. The production OIDC role has narrower permissions than staging, it can only trigger ECS updates, nothing else. After a successful deploy, the final step creates a Git tag tied to the workflow run number, giving you a clean handle for rolling back to any prior production deploy simply by knowing which release tag it carries. Strong pipelines practice defense in depth, multiple independent layers, each stopping a different failure mode. The permissions ceiling prevents privilege escalation by compromised actions. OIDC eliminates the entire class of leaked long-lived credentials. SHFpin Docker images make tag drift and supply chain substitution impossible between staging and production. Environment protection rules enforce the 4ICE principle so no single actor can deploy unilaterally. Matrix tests across 3 node versions catch version-specific bugs before any image is built. And the concurrency cancellation prevents 2 simultaneous deploys from stepping on each other. Remove any one of these layers and you introduce a real attack surface or failure mode. One of the underappreciated strengths of GitHub Actions is the observability it gives you for free. Every deployment to a named environment appears in the Environments tab with a timestamp, the deploying actor, and a link to the exact workflow run and commit. Every pull request shows all 5 jobs, including each of the 3 matrix variants, as individual required status checks, so the green board before merge is unambiguous. Reviewers approving the production deploy see a direct link to the staging deployment URL in the full diff, giving them real context rather than a context-free approval click. The audit trail here is not a separate compliance tool, it is the workflow itself. This pipeline is production ready, and it is also a foundation you can keep building on. Dependabot is the highest leverage next step. It opens automated pull requests for dependency updates and action version bumps, keeping your security surface current without manual tracking. Slack notifications using the Slackcopy GitHub action give your whole team visibility on every deploy without needing to watch GitHub. Playwright Cypress end-to-end tests running against the live staging URL catch regressions that unit tests cannot see. And Release Please automates your changelog and semantic versioning from conventional commit messages, turning your Git history into structured release notes. You started this course with a scenario every engineer knows: Friday, 4:57 p.m., a deployment that nobody is confident about, and a weekend potentially ruined by a production incident. You now have the tools and the understanding to make that scenario impossible. Every commit you push is automatically tested across multiple runtime versions. Every image that reaches your registry is uniquely identified, immutable, and tied to a specific commit. Staging catches issues before humans ever have to make an approval decision. Production is behind a gate that enforces accountability and creates a permanent audit trail. You have transformed the deployment from a moment of anxiety into a reliable, observable, repeatable process. Friday 4:57 p.m. is just another deploy now. This final question tests the most important architectural distinction in the entire pipeline. The needs keyword is about ordering. It makes deploy production wait for deploy staging to finish, but a finished job is still automatic. The concurrency group prevents parallel runs of the same workflow, useful for avoiding race conditions but requiring no human action. The environment production declaration is the only mechanism that actually pauses execution and sends a human being an approval request. It activates the protection rules you configured in GitHub settings. Understanding that difference between automated ordering and human-gated approval is the core insight of this entire module.